Do you guys know what extrapolate means? I mean, it's a hard thing to do on a board here freehand. But what extrapolate in this particular case means is taking a line and say, well, I know the line doesn't cross that x-axis, but if it did cross the x-axis, where would it cross? Now, the neat thing they found about this was that every single gas crossed in the same spot, that same sweet spot, that just happened to be negative 273.15 Kelvin, degrees centigrade, which they refer to as 0 Kelvin. Now, there's a speed limit in the universe, and the speed limit of the universe is the speed of light, okay? Nothing travels faster than the speed of light in a vacuum. If anything did, then like physics and things would have to be changed, all right? Nothing that we know of as of today does stuff like that. Okay, now this is also a speed limit, quote unquote, a temperature limit. Nothing gets colder than 0 Kelvin. There's been lots of people try, and they've never been able to make 0 yet. And last I heard, they were like at 10 to the minus 9, all right, or 10 to the minus 6. So they're getting close to 0, they just have never been at 0. So that's important if you're doing like gases, where you have volumes in there, because here's the thing, you cannot have a negative volume. You cannot have negative pressures. I mean, you have to have liquid or no liquid, but you can have like negative water, all right? So that's why this Kelvin deal is worth talking about. So, as you guessed it, what would you do if you had to convert back and forth? Well, the first one is simple, and that is if you're converting between these two. One of the things you'll notice, they're linear. What do I mean by linear? I mean that there's exactly 100 spaces between here and here, and exactly 100 spaces between here and here. So what does that mean? Well, anytime you've got a degree centigrade, all you have to do is add 273.15 to it to get a Kelvin temperature. There is your first temperature conversion formula. If you'll flip to the back of your book, like back there where you see cardboard, they have a little cheat sheet for you. Now, you're not going to get that cheat sheet on the test, all right? You will get the conversions as I've promised you. But these right here, the formulas, you have to know how to go back and forth, because that happens so frequently in chemistry, you need to know how to do that, all right? Now, what's another one there? Do you see 1.8 degrees centigrade plus 32 equals your degree Fahrenheit temperature? All right, so when would you use this thing? You would use this thing if you knew a degree centigrade temperature, okay? And you wanted to go to Fahrenheit, for an example. You're watching the news in Spain. The weather lady tells you it is 30 degrees outside. What is the temperature? All right. Well, first off, in Spain, they're going to be using the degree centigrade deal, so that's 30 degrees centigrade. Add 32 to it, and what is my degree Fahrenheit? 1.8 times 30 plus 32, 86. All right, so that'd be 86 degrees Fahrenheit. So the weather lady tells you it's 30 outside. Would you wear shorts or pants? Certainly you'd be wearing shorts, probably. I mean, not necessarily, but probably. All right. All right, are we good? So does anybody want to know where the 1.8 comes from? Does anybody know?
Yes.
You want to know. You know?
I want to know.
You want to know. Wonderful. All right. What's 212 minus 32? 180. Okay. So what is 180 divided by 100? 1.8. All right. You got your answer? All right. Where's the 32 come from? Well, guess what? This starts at 0. Where does this start? At 32. So you're going to have to add 32 to it to bring it back up. All right, so that's where the 32 comes from. Now, some textbooks have this formula. All right. Yours does not. But some textbooks say this. I think the A&P textbook does this. Look at the 9/5. Where does that come from? What's that now? 180 divided by 100, right? Because if you simplified this fraction, it would be 18 divided by 10. 2 into 18 goes 9 times. 2 goes into 10 5 times. Right? All right. So, you know, a lot of times in science, I mean, we got reasons why things happen. All right. Now, what if you want, let's see, one more here. What if you wanted, if you had a degree Fahrenheit and needed a Celsius? What would be the formula? Can you guys get that from this? Degree Fahrenheit minus 32 divided by 1.8 equals the degree centigrade thing. What did I do? I just algebraically rearranged that. All right. So these three equations right here, actually these two equations, the first two, will get you back and forth between anything. Now you might have to algebraically rearrange something. All right. But they will get you back and forth between all of your temperature scales. All right. Are we good? Okay, let's take a break and come back and do some more.